Hello, good morning to all. Welcome back. Today I'm going to discuss about the IO handling algorithms, input-output handling algorithms. Under this system, there is the fast FCFS, fast come fast serve, SSTF, statistic time fast, scan, look, n-step scan, C-scan, and C-look. So first come to the FCFS, fast come fast server. It is one of the simplest device scheduling algorithm since it is easy to program and essentially fair to user IO devices. The only barrier could be the high seek time, so any other algorithm that can surpass the minimum seek time is suitable for scheduling. So this is a fast come fast scheduling, but it is the time taking process. Next is the statistic time fast SSTF. We use the same ideology as the shortest of fast in process scheduling. By shortest process as short fast and longer process have to wait for their turn. Next is your scan algorithm. Scan uses a status flag which tells the direction of the arm. It tells whether the arm is moving towards the center of the disk or to the other side. This algorithm moves arm from the end of the disk to the center track and servicing every request in its way. When it reaches innermost track, it reserves the direction and moves towards outer tracks on the disk, again servicing every request in its path. That means that is a disk or circular disk type. That is it moves towards the center of the disk and to the other side. It is continuously moving from the center of the disk to the outer track of the disk. Between that, from center to the outer track, all data will be scanned, and this is the scan algorithm. When it reaches innermost track, it reserves the direction and moves towards outer tracks on the disk, again servicing every request in its path. Next, look, elevator algorithm. It is a variation of scan algorithm. Here arm does not necessarily go all the way to either side on disk unless the request pending. Next is the other variants of scan. There are a number of the scan related algorithm, n-step scan, where it holds all the pending requests until the arm starts its way back. New requests are grouped for the next cycle of rotation. C-scan or circular scan. It provides a uniform wait time as the arm serves requests on its way during the inward cycle. To know more, refer difference between scan and C-scan. For C-look, arm does not necessarily returns to the lowest number track. It returns from the lowest request to be served. It optimizes the C-scan as the arm does not move to the end of the disk if not required. To know more, refer to the difference between C-look and C-scan. Next is your IO buffering, or the concept is the buffering. A buffer is a memory area that stores the data being transferred between two devices or between a device and an application. So buffer is a temporary memory area. Next is your uses of IO buffering. Buffering is done to deal effectively with a speed mismatch between the producer and consumer of the data stream. A buffer is produced in main memory to heap up the bytes received from the modem. After receiving the data in the buffer, the data gets transferred to the disk from buffer in a single operation. This process of data transfer is not instantaneous, therefore the modem needs another buffer in order to store additional incoming data. When the first buffer got filled, then it requests to transfer the data to the disk. So there are different types of I/O buffers are used. One is a single buffer, and another one is a single buffer. Next is a double buffer. Next is a circular buffer. So first come to the single buffer. A buffer is provided by the operating system to the system portion of the main memory, and again this single buffer is implemented over two streams. One is your block oriented devices, where the system buffer takes the input. After taking the input, the block gets transferred to the user space by the process, and then the process requests for another block. Two blocks work simultaneously. When one block of data is processed by the user process, the next block is being read. Operating system can swap the process here. OS operating system can record the data of system buffer to user processes. Next is there is another stream oriented device. Line at a time operation is used for scroll may terminals. User inputs one line at a time with a carriage return signaling at the end of the line. Byte at a time operation is used. Byte at a time operation is used. One form mode terminals with each keystroke is significant. So these are the single buffer. Let's come to the double buffer. Again, the double buffer also block oriented and the stream oriented. There are two buffers in the system in the case of block. One buffer is used by the driver or controller to store the data while waiting for it to be taken by a higher level of the hierarchy. And other buffer is used to store data from the lower level module. Double buffering is also known as buffer swapping. Next is the stream oriented. Line at a time I/O input output. The user process need not to be suspended for input or output unless process runs ahead of the double buffer. Byte at a time operations, double buffer offers no advantage over a single buffer of twice the length. Next is your circular buffer. When more than two buffers are used, the collection of buffers is itself referred to as a circular buffer. In this, the data do not directly pass from the producer to the consumer because the data would change due to overwriting of buffers before they had been consumed. The producer can only fill up the buffer while data in buffer I is waiting to be consumed. That is the circular buffer. That means when the more than two buffers are used, the collection of buffers is itself referred to as a circular buffer, and the data do not directly pass from the producer to the consumer because the data would change due to the overwriting of buffers before they had been consumed. And the producer can only fill up the buffer while data is in buffer I is waiting to be consumed. So this is all about the single buffer, double buffer and the circular buffer. The next class we have to discuss about the spooling. So thank you for this class.